Welcome, everyone. Today's webinar is about how StoryFit makes revenue impacting predictions using automated machine learning. I'm Dylan Tong, and I'm a machine learning partner solutions architect from AWS. I'll be your webinar host today. Before we jump into the presentation, I just want to make sure everyone is comfortable with the web controls. If you wish to change your audio settings between phone and computer audio at any time, you can do so from the audio pane on the control panel. You'll also be able to submit questions for the presenters throughout the presentation through the same control panel. We'll answer as many questions as we can during the QA session at the end of the webinar. If there are unanswered questions, we will follow up by email. The presentation deck will be made available on SlideShare, a webinar recording on YouTube, and we'll send a follow-up email a few days after the presentation with links to these resources. And last but not least, we will have a survey at the end. We greatly appreciate your feedback. It helps us continually improve your experience. So without much further ado, let's get on with the presentation. Today's webinar is a joint presentation by AWS, DataRobot, and StoryFit. We're going to start out with a brief history of AI at Amazon, understand how it has evolved and enabled partners like DataRobot and customers like StoryFit to innovate. Then we're going to learn about DataRobot's platform, see it in action, and how it enables customers like StoryFit to rapidly build intelligent applications. And last but not least, we're going to hear about StoryFit's journey to achieving revenue impacting predictions. With me today are two very special guests, Corey Kine, a data scientist from DataRobot, and Mark Bezin, who's the CTO of StoryFit, and of course myself, Dylan Tong, machine learning partner solutions architect from AWS. Briefly about Mark and Corey's companies, StoryFit puts the power of AI in the hands of publishers and so they use AI to help storytellers predict the commercial potential of a story by turning the intangible elements of a good story into something measurable. DataRobot offers an automated machine learning platform. It solves business problems by automatically finding the best predictive model given data, accelerating time to value. StoryFit is a customer of both AWS and DataRobot, and DataRobot is an AWS ML competency partner. So a bit on the significance of the AWS ML Competency Partner Program. This program represents the pinnacle of ML partner expertise on AWS. The achievement involved continued demonstration of excellence, technical proficiency on AWS through certification programs and well-architected reviews. DataRobot was then hand-selected. We validated them on machine learning expertise and a proven record of customer success in machine learning on AWS. So now for a brief on a long history of AI at Amazon. We've been making investments in AI for the last 20 years, and it has played a critical role in the company's success. So I'd like to take a moment to share some examples and let it be an inspiration for you in terms of what's possible. Sometimes our AI technology is operating in the background without you even knowing it. Every time you click and you buy a product on Amazon.com, these little robots you see here called Kivas are busy working alongside humans to automate and improve the efficiency of logistics in our warehouses. And then there's personalization, right? Most of us have been acquainted with product recommendations on Amazon.com for a very long time. But personalization also comes in different forms like targeted campaign, content, intelligent ad placement. Some of you might have even heard of the concept of item-based collaborative filtering. This is a machine learning technique that Amazon invented in 1998 to drive personalization. Today, we also leverage modern deep learning techniques like HRNNs that take advantage of large amounts of user interaction data to represent customer interests, take into account temporal purchasing behavior of consumers to ultimately deliver a more personalized experience. In some cases, we also leverage computer vision in conjunction, extract visual features of certain products to learn and predict the stylistic preferences of consumers. In other cases, Innovation is front and center and conceptually unique. You can take the Amazon Go here as an example, where we've reinvented retail experience. Now, when you enter an Amazon Go store, you swipe a mobile app, there's smart cameras that identify you, and there's cameras throughout the store that leverage computer vision technology to track the movement. So just like the customer that you see in the video, you take a cupcake, it's tracked, you change your mind, it's okay. Amazon Go knows that you put it back. Eventually, you make a decision and you make your selections. You can just walk out and you're automatically charged for your selections. From my personal experience, it feels to me like the store is like my personal fridge. And of course, there's Alexa, right? Pushing the envelope around conversational AI into the norm with over 100 million devices sold to date. There has been so many clever applications, including the use of Alexa as the interface for smart homes. Amazon is also a well-known adopter of open source technologies, but we appreciate the importance of giving back to open source communities. So for example, Apache MXNet is an open source deep learning framework. It originated from academia at Carnegie Mellon University and the University of Washington. Amazon adopted the framework in 2016, and since then has made regular contributions to the net project. And last but not least is the AWS AI stack, broad and deep capabilities designed to cater to the needs of varying levels of expertise. At the bottom of the stack, we have best-of-breed infrastructure designed for expert machine learning practitioners. In the middle, SageMaker, a service that automates the end-to-end machine learning process. And at the very top, a wide range of services designed for application developers to build intelligent applications without the need for data science expertise. And we are delighted to have a vibrant ecosystem of partners and customers developing machine learning solutions using AWS AI, startups, enterprises across all verticals. And up next are a couple of the incredible examples of what's possible, DataRobot and StoryFit. So please welcome Corey Kine from DataRobot.
Hello, thank you for that introduction. My name is Corey Kine. I'm a customer-facing data scientist with DataRobot. So let me see. Can we go to the next slide? Great, thank you. So the best way to understand DataRobot is to see a demonstration. I know StoryFit is going to discuss a number of their own use cases later on, but I'm going to show a few of DataRobot's capabilities on a much simpler use case, which is predicting the sentiment of a movie review posted to social media. So what we're talking about today, and you're seeing in front of you, is something called supervised learning. Supervised learning is a method whereby we use past data to predict future values of some outcome. We start with a concrete outcome that we're trying to predict, which is our target over here on the right. The model then learns from historical examples to build a model and predict those future values on new or unlabeled data. So in this case, for training, we're going to use IMDb movie reviews to identify words and phrases that predict a negative review. This data is open source data from IMDb, the movie database. We're just looking at reviews that have positive or negative sentiment. We also have the full text of the review. So this is going to allow us to learn what words or phrases, or n-grams in the natural language terminology, predict a negative review, and then apply that to other reviews where we don't have that explicit positive or negative tag. So this is an example of a positive review. I looked it up, and it's actually about the 1989 film All Dogs Go to Heaven. There are a couple of things that I want you to notice here. This is free text, so there's a lot of complicated syntax. So within DataRobot, there's no limit to how long the text can be. We're also capturing natural human language with all of its different complexities. So those of you with keen eyes will notice misspellings, grammatical errors, and other sort of unique features of human language. This is important because that's what humans create. That's what you're going to see in the real world. There are also some interesting negative phrases within this overall positive review. There's things a reviewer does not like. The idea is that by looking across lots and lots of reviews, The algorithm can learn what's meaningful and what's not. And most importantly, we have this overall summary. This is a positive review. So why do we want to do this? Now that we've looked at an example of training data, we're going to pull up and think about the use of this. So with the IMDb review we just looked at, IMDb forces reviewers to give an overall tag. So that was a positive review. But let's imagine a use case now where we want to automatically promote positive tweets about films in real time. In this case, the film example you're seeing predates Twitter. This is from Lion King 1.5, but you can imagine this is a new movie coming out today. This is where a situation where the tweets won't have a label as positive or negative. We just have the text by itself. And this is where you can see the value of that model. We're going to use this model to predict which reviews are negative so that we can automatically filter those out when we're promoting the film real time. So I have used DataRobot to create a model. So let's dig into some of the results and how it's working behind the scenes. So this is one of the ways that DataRobot measures accuracy. This is called a lift chart. We've split all the reviews into the ones that we're predicting on into 10 equal size buckets. We're predicting negative reviews. So on the right here, we can see the reviews that are most likely to be negative. We use this chart to show rank ordering. So if we take data from the bucket all the way on the right, the model's at 99% sure that these are negative reviews. Those are more likely to be negative than the next bucket to the left, and so on. You can see that across the whole data set, all these buckets together, we've tagged about 91% of these reviews correctly as positive or negative based on the text alone. And importantly, I want you to understand these are measures based on holdout data, so data that a model hasn't seen before. So we've set aside data at the beginning that the model has not seen, and these accuracy measures I'm talking about are all in relationship to that holdout data. So we're talking about text, so I had to show a word cloud. Most of you will have seen these before. The idea is that every word or phrase gets a coefficient indicating how positive or negative it is across all the training data. The size indicates how often that word appears. So some of these seem obvious. You'll notice, excellent, love, favorite, wonderful, classic are all positive. Those are blue, so these are very unlikely to be negative reviews. But there are some actually here that seem a little bit more surprising. One of my favorites is the word decent, which is on the left about halfway down. And in normal language, we might think that would indicate something neutral or maybe even a little bit positive. But in the context of these movie reviews, it turns out people are actually saying something was decent in the negative context. So it's more indicating the absence of a more positive word, which is a negative indicator. So these word clouds, though they are extremely simple, can actually still be extremely helpful. So DataRobot has a lot more tools around accuracy, some of which you'll see later. But I want to make sure that I show you how DataRobot creates these models. This is something we call the leaderboard, which is sort of the core of DataRobot. DataRobot's approach to modeling is akin to something like survival of the fittest. So when you upload a data set, DataRobot's going to automatically select about 40 different blueprints based on the data that was uploaded. A blueprint that I mentioned is not actually just a model. It's a model plus whatever pre-processing steps are going to be most appropriate for that model. And this is important because the modeling folks on the phone will recognize that pre-processing is often unique to different kinds of models, and that can be a big time expenditure for teams. So this means that you can run all kinds of different models against one another without creating all the separate pre-processing steps required for each one. DataRobot's going to run these different blueprints in parallel on the data you've uploaded. Then it will compare the performance of these models against each other to figure out which approach, whether it's a linear or logistic model, a tree-based model, or something much more complicated like a neural network, is performing the best on your specific data. All these models end up on a leaderboard, which is what you're seeing here on the left, and we're sorting them by the most accurate on that cross-validation measure. So in order to run all these blueprints simultaneously, we rely on Amazon Web Services. This is a really high-level overview of the DataRobot infrastructure. On the left, you can see that we get data via the UI or the API for training. During the training step, data runs each blueprint on one of these modeling workers that you see here in the middle. Each of these workers is a 32 gigabyte RAM, 4-core AWS server that we can run in parallel and start and stop on demand. This allows customers like StoryFit to explore and train many models simultaneously. On the right, we've picked a model, we've deployed it, and we're using these predictions in practice. And an AWS architecture underlies everything and makes all of this possible. I will mention, though, as well, what I'm showing today is from our Amazon cloud, but DataRobot is also compatible with virtual private clouds and on-premise options as well. So since the core idea of DataRobot involves sourcing and comparing all these different models from across the field of data science, we don't necessarily assume people are going to be familiar with every single one of these models. And so if you're going to use a model in practice, understanding it and trusting it is key. So that means data transparency. This is an example blueprint, as I've been talking about. On the left, you see that this blueprint includes categorical, text, and numeric variables. For the IMDb use case we've been talking about, we're just using text data, but it's much more common to have multiple types of data together. And all these different variable types have different pre-processing, like I mentioned, such as missing value imputation or categorical encoding. And you can see here in this blueprint that DataRobot does that automatically for you, but we provide full information about what's been done so that you can interrogate that yourselves. So in order to trust these blueprints, you really have to understand them. So every one of these nodes across every single blueprint we offer has complete documentation detailing what's going on, what hyperparameters were used, as well as specific background on that approach. So you can see here on the bottom right, this is a little informative pop-up that you can see on every single one of these nodes in every blueprint. And then if you click on the documentation, that's going to open up a lot more information as well to really make these available and accessible to people with a variety of different kinds of data science backgrounds. One thing we hear commonly from customers is that once we're developing models, understanding trade-offs is really important. And one of the core ones is often speed and accuracy. That's what you're going to see on this chart here. Each blueprint that we ran is represented as a dot on the scatter plot. On the x-axis, you see scoring speed. On the y-axis is accuracy, and in this case, lower is better. Obviously, the trade-off between those is going to depend on your use case. So in the example I gave, where we want to identify real tweets, real time, which tweets are particularly positive or excluding those that are negative, that's a use case where speed is important and the cost of getting something wrong are relatively low. But for other use cases, let's say, for example, healthcare, we may care a lot less about speed for scoring and more about making sure that we're getting as accurate models as possible and making very, very few mistakes. So in that case, DataRobot can help you navigate those trade-offs and pick the right model that's appropriate for your problem. Another thing that we want to help you understand is what you might need to do to make models perform better. So what you're seeing here is how well this model performs, or all these models perform, as we increase the amount of training data that we used. So this data set is relatively small. In this case, when we use 64% of our training data rather than 32% of our training data, we're seeing a pretty big improvement in model accuracy. Again, lower is better here. So when we increase the amount of training data, those models get more accurate. That's a good indication that this model that is going to continue to improve when we add more data. So that might prompt us to source more tagged movie reviews, Maybe look for more historical information that we could pull in. This is also a pretty narrow data set. We just have text, no additional features. But in StoryFit's case, as we're going to hear, they generate hundreds of additional variables through feature engineering to make that data wider as well as longer. So what hopefully you're seeing here is that we really try and focus on democratizing data science. So we make data science available to analysts by automatically instituting smart guardrails, but we also provide total customization for more advanced users. So on the left, you're going to see the hyperparameter tuning that DataRobot has done automatically for us. So it'll identify some hyperparameters that make sense to explore further. It'll try different combinations of those and pick the ones that perform the best. However, if you have experienced data scientist practitioners on your team who are more familiar with advanced tuning, with certain model types and have some expertise, you can see here on the right that these people have total control of the platform to try and improve on what DataRobot has done by creating their own sets of hyperparameters to tune manually. So there's that balance of what DataRobot will do for you to have those guardrails in place, and then providing customization for users as they become more expert and know the content more effectively. So this has really been a high-level demo. There's a lot more to DataRobot, but and I encourage folks to ask questions as you have them at the end. But at this point, I want to turn it over to Mark to talk about how StoryFit uses all of this in practice.
Great, thanks so much, Corey and Dylan, for the great setup and for the demo of DataRobot and an understanding of all of the AI and ML solutions that AWS has to offer. Okie doke. So I'm going to talk about how StoryFit has leveraged DataRobot and AWS to provide machine learning driven predictions for how viable story-based content is, whether it's books or screenplays, in the entertainment industry. So we are leveraging all of the technology that Corey and Dylan have presented in order to apply that to a very specific application, which is the understanding of long-form narrative. And so really, we are working primarily in publishing, movies and entertainment, and on the TV serial side, but there are lots of applications of StoryFit's technology to OTT platforms, brands, and advertising as well. So the real traditional way of targeting audience is to use features of a story like genre, tone, plot, character in order to find the right audience. And that audience in recent years, with the proliferation of streaming, has really gotten extremely granular. So it may be that a specific audience is users who like watching comedies on a Wednesday right before they watch The Handmaid's Tale. Or it might be something like users who watch The Bachelorette and then switch over to another reality TV show. So because audience has gotten so granular and finding the users who are gonna consume content is extremely fine-grained, we've really needed to explode the data set of data that we have on stories as well in order to train the most accurate machine learning models to target that specific audience. So really what StoryFit does is provides extremely granular data on the aspects of story that matter to viewers, from the characters to the tone to the pacing of the action sequences, in order to train the most accurate machine learning models to predict the viability of content for specific audiences. So I'm going to talk first about how we engineer and extract thousands of features from stories themselves, and then how we use platforms like DataRobot hosted on AWS infrastructure to train predictive models and assess their accuracy. This data can then be applied throughout the content lifecycle within both studios and publishing. So because our technology is operating on the text itself, whether we're parsing a manuscript of a book or the screenplay for a movie, it can help as early as the acquisition step in assessing the viability of the content. We can compare multiple versions of screenplay drafts during the creative development process and predict which ones will be most well received in specific audience segments, which can help with greenlighting efforts as well. If a studio is trying to figure out what sort of budget to allocate to a specific project, they can get a good sense for the audience size as soon as they have a screenplay. So this is really a tool that we've used to help studios mitigate the risk of their investments and optimize the marketing efforts and campaigns to find as many potential audience groups as possible to get their content, their stories, into the hands and eyes of the right viewers. And so part of machine learning that Corey was mentioning is that it's really based on the corpus you're training on. So having a large corpus of content is absolutely crucial to having the most accurate predictive models. So we've really curated a data set of the largest set of narrative content out there on the market to make sure that we're staying well aware of all the trends that are occurring in the entertainment industry, that we have representations of every different type of content, whether it's children's books or extremely intense content on HBO. So we've got over 20,000 scripts. We've measured the personality of over 80,000 characters. And because a lot of these stories are derived from books, so whether it's Gone Girl being made into a feature film or Big Little Lies coming out as a mini series on HBO, stories contain core elements that are measurable using StoryFit's technology in a way that hasn't been available before. So I'm going to go into some of these features that we measure. You can see some examples here about the emotion and pacing, the sentiment arc of the story, and I'll go into a little bit more granularity with hopefully some examples of movies that you're familiar with. And essentially, the step we take is going from a long form piece of narrative into a structured data set that we can then put on a platform like DataRobot to train predictive models. So as opposed to just plopping the full text field in, when you have a 200-page screenplay, the results of just using it as a text field are very limited. So we've created specific pre-processing steps for StoryFit's cases in order to get a data set of story features that we can then apply a target, just as Corey was telling us, whether it's the opening weekend earnings or the percent of the audience that will be female, and use that structured data set of content from the story itself to train those predictive models. So let's first talk about what some of those features are that we apply or that we derive from content. One is looking at the topics and themes that make up a story. So we use unsupervised machine learning models, specifically topic models, to derive all of the frequently occurring topics in a specific project. And we know how frequently each of those topics occurs, not just in this movie, but in every single one of the 20,000 other movies that we have screenplays for. So we can identify which ones stand out and which ones are commonplace or kind of required as baselines. And so we know that for action movies, Guardians of the Galaxy has particularly high references to drinking and booze, space and outer space, and has lots and lots of fast transitions. So you can see that many of our features are thematic, some are character-based, some are based on the pacing of a story. And so using these machine learning derived topics, we have a structured data set of the same topics being measured in every single screenplay, as opposed to just applying off-the-shelf NLP, which is trained on things like tweets or reviews, but not specifically on long-form narrative, we've trained topic models specifically on the content of long-form narrative in order to have the most accurate representation of a story. Because we're parsing out a screenplay, we also know a lot of information about the characters. So we know how much of the dialogue in the story is spoken by male versus female characters, how many characters there are central to the story and how many are peripheral. And we also have a lot of granular features about how they're interacting. So we know, for example, that Guardians of the Galaxy is made up of a network of 7 major characters who all have significant portions of the dialogue, but that Gamora, Quill, and Drax are really central to this character network. The advantage of something like a character network is that not only is it a useful visual representation of the screenplay, so you can see if, for example, 2 of your major characters don't actually interact significantly, but it's also a structured data set about this content that has features like the number of nodes of the network, the number of connections between those nodes, how many distinct communities are represented in the character network, and all of those features go into training our predictive models and making sure that we're representing the content in a way that is familiar to the creatives and users that are going to be applying these predictive models in their creative production lifecycle. We can also measure things like the emotion and tone of the story and compare that to the average for that particular genre or to movies overall. So for example, we know that this particular movie, Guardians of the Galaxy, is significantly high in anger, sadness, and joy, but doesn't have strong elements of disgust or fear. And we know that typical for an action movie has a little bit more fear than this particular one. So it's more of a lighthearted action than is often the case. The advantage of using sentiment analysis is that we can apply it not just to the movie overall, as you see here, but look at the actual narrative pacing of the story as well. So that may be something like the structure and style. So this particular movie has a lot more scenes on average, or a lot more scenes than the average for an action movie. And each scene has a lot less dialogue. So this movie is moving at a much faster clip, has more transitions and fewer characters speaking per scene than typical for an action movie, which contributes to its fast pacing and really clippy feel when you're watching it. We also know if this movie has dramatically more interior or exterior scenes, if the scene locations, whether it's occurring on a spaceship, is typical for the genre or extremely rare. And we can also look at really, really granular detail about the characters themselves. So let's switch over to Katniss, away from Guardians of the Galaxy, and we can take all of the dialogue that is spoken by an individual character and run it through personality and emotion detection models in order to get a really great way to understand who these characters are in a way that resonates with viewers and creative folks. The other advantage is that we then know all of these attributes. We measure about 150 personality and emotion attributes per character. So then we can compute how similar Katniss is to every other character from every other screenplay that we have and find those that are most similar to her. Because we're operating on the actual text spoken by Katniss, it is a really interesting way to see if she is speaking in a manner that's typical of male characters or female characters, whether she's extremely similar to the other characters in her own movie, or if they're all distinct, and get a really great quantified and structured data set on this character's personality that allows us to compare it to every other movie that we have in our system. We may also want to see where all of the fear is occurring in a particular movie and whether there's tons of fear at the beginning but none at the end. So we can look at the per scene emotions in order to quantify the pacing of this particular story. And so we measure this along a number of different dimensions, including these 5 emotions, and can see where the most intense scenes are occurring, if they're evenly spaced out, and whether there's too long of lags between intense scenes that are contributing to the narrative feeling slower or falling off. And again, the advantage of doing this at scale is that you can compare this movie's narrative pacing to that of other young adult action films, or to other movies featuring a strong female protagonist. Any subset of comparisons that you're interested in are possible with this sort of structured data. And now let's get to where we apply that structured data set of story features to make our predictions for how viable content is in the marketplace. So we have a number of regression models that are used on feature sets derived from the narrative content itself. And so really these serve as kind of a bottom guardrail on how well a movie will perform in the market. Because our models are built only on the story features, things like the characters and parsing out of the screenplay itself, we can provide these rating predictions as early as the acquisition step, even before someone has read this specific script, to move it to the top of the stack and say, hey, this looks like a project with a lot of potential. Let's read this one first. So these are taking our structured data set of stories to predict things like the IMDb rating and the Rotten Tomatoes rating, even before we know that Chris Pratt is going to be the lead of this movie. And so then when we include those additional features, which we have models that include the production related details as well, our models only increase in accuracy. We also have predictions for the percentage of the audience that'll be female, whether the audience will skew young or old. So any different target that we're trying to predict, whether it's the rating, the box office revenue, or the specific demographics of the audience, we can train dozens of different models at scale using technology like DataRobot, while allowing our data science and engineering team to focus on measuring those elements of narrative in a way that's unique to StoryFit, and then applying those to the DataRobot application to make these sorts of predictions, and just run lots of different predictions to see which ones are most accurate. We also, so on DataRobot, as Corey mentioned, we do lots of different supervised machine learning models. The ones that I just discussed were on regressions, but we also have classifications. So if at the point that a studio is acquiring a screenplay, they just want to know the specific genres that it fits into, our technology can very accurately predict the genres based on just the narrative features that we measured from the screenplay. So each of these genre predictions is actually an individual machine learning binary classification model. And so we've done these for these major genres, but we can also train predictive models like identifying a dark comedy, or really specifically identifying movies with a strong female protagonist. And because we're measuring the elements of the story itself, we're able to get great accuracy with a lot of these different classifications. You may also just want to know what rating this movie is going to get. That kind of provides you a sense for how large the potential audience is for a movie. If it's rated R, you know that in the opening weekend theatrical release, you're not going to get users under age 18. And so PG-13 movies have a larger opening weekend potential audience. But we also, and so the MPAA rating prediction, we have over 95% accuracy at identifying the MPAA rating just based on the screenplay itself. And we can also give a lot of granularity in terms of why that screenplay got a certain prediction. So each of these parental advisory predictions that you see here is a multi-class classification as well, where the target is sex and nudity, and the different classes will be mild, moderate, severe, or none. So then we can actually give really granular quantified attributes of how violent and gory this movie is, whether it's rated PG-13 because it's high in alcohol, drugs, and smoking, or because it's high in sex and nudity. And so these content advisories are really key to the industry in figuring out not just who's going to go to the movies, but who's going to enjoy them. It also gives parents who are going to be viewing content a lot more control over what their kids are seeing. So if there's a parent who knows that they are totally fine with profanity but don't want their kids to see any violence and gore, we can automatically flag all of those particular metrics for the studio to know at the point of acquisitions exactly where this project measures. So these are some of the multi-class classifications that we have that are all powered by some of those story elements. These then become features in our models that we use to train things like identifying the identifying the IMDb rating. So that's kind of an interesting way that we can chain together these models and say, use the output of our genre classification models to tag the movie with genres and feed that into our machine learning based regression to identify what percentage of the audience will be male or female. I wanted to go over a little bit of a kind of real world application of what Corey was talking about in how we can actually leverage this to measure which models are most accurate for our specific training target. And so this is one particular model, which is identifying if a movie is an action movie or not. And so all of our features, everything from the themes to the characters, are inputs to this model. And then the output is a prediction of whether or not this movie is an action movie. So this could be used if you have a studio who has 200 scripts and they want to know which ones are a drama but that have a significant action element. We can automatically run our analytics on those and get that data right at the point of acquisitions. And we can also give insights on why. So you can see that the number one feature in predicting whether a movie is an action or not is speed. So the word speed occurring and also speed as a feature that we're measuring via narrative pacing allows us to see what is driving the prediction for whether something is an action or not. And all of that can get rolled up into our AI-powered movie comps. So we're measuring all of the character, genre, story elements, the tone and intensity, and can then, based only on the screenplay, compare how one particular piece of content looks in the entire marketplace because we have all of these different quantified structured metrics on the story. Many of these are our genre predictions, so we can predict the genre of all of these different pieces of content in the same manner and then compute how similar all of those predicted genres are. We can do the same with our character networks, same with the setting and intensity, and really give studios a way to find all of the possible comps that appear in the entire marketplace in a very, very quick manner and with great accuracy. We have over 130,000 movies and TV series in our comp tool. And so anytime you're finding comps for one particular project, it computes how similar that project is along all of these dimensions to every other one of the 130,000 plus projects in our system in order to make sure you're not missing comps that may be extremely relevant, but perhaps you have a theatrical release and we're not looking at comps that were on streaming platforms. All of those are integrated into our centralized database in order to make sure you have the best sense of where your content fits into the market. So you can go to StoryFit.com to check out all of these different tools. But with that, I'll hand it back off to Dylan and get some questions about this technology in the wild.
Thanks, Mark. This is a very, very innovative applications of AI. So on to the Q&A session. Again, you can ask questions by typing in your questions through the questions pane on the webinar control panel. With that said, we already have a few questions from the audience. This first one is a question for both Corey as well as Mark. one of the attendees is wondering which programming language and patch did you use for all this? And let's start with Mark and then Corey.
So StoryFit has all of our infrastructure hosted on AWS, but we access all of it kind of via Python commands. We also use the prediction server API and just call the DataRobot API within our Python code, which is a great way to make sure that we're managing all of our models in production, but able to integrate them into our machine learning pipelines really easily. So we then also Dockerize all of our products so that they can be hosted on-prem as well. And because DataRobot has that ability, it's a really straightforward system to go about hosting all of our technology on-prem as well. But really, all of our feature engineering is done in Python, and a lot of these are custom models that we have specifically trained in-house at StoryFit.
Sure, I'll speak to that as well. So deployment with DataRobot, there's a number of ways you can do it, from a sort of manual within the UI all the way out to deploying on Hadoop. What's most common is that people will call the API. As Mark mentioned, you can call a prediction API to get results back. Every single model on that leaderboard I showed you is a REST endpoint. So it's anything that your system can make REST calls, we can use to get predictions out. The other thing I'll speak to is actually developing the models themselves. So what I was showing you was the user interface, but many of our customers actually do all of their model training and evaluation through the R and Python packages that we've released open source. So if you are Python users and you want to automate more components of that model training process, everything that I did in the GUI is also available via the API.
Great. Okay, so we have another question. Question is for Mark from StoryFit. How does StoryFit's tech differ from other NLP?
That's a great question. And part of it is that we also apply all the existing NLP technology that we can find to our pipeline as well. So whether it's things like detecting all of the entities that are mentioned in a screenplay, or all of the concepts and categories and emotions. But really, because we're working with narrative content, we've engineered specific features that are most relevant to our creative users. So that may be things like whether it's a male or female protagonist, whether it's a happy or sad ending. And so in my work as a data scientist, I've really seen that the best features are those that are engineered with a specific industry goal in mind. So it may be that a studio is trying to figure out if their character network has too many characters in it, but starting with the questions that the creative teams in studios are asking and finding ways to measure those quantitatively is how we really differ, is that we're looking at specific narrative elements, like whether there's a major plot twist within the first third of a movie, or whether there's whether we meet the protagonist in the first scene or whether we meet them a few scenes later. So a number of these features that are really specific to stories and to the way that humans consume stories is how we build features that are distinct from traditional NLP, but we also do apply everything we can from kind of off-the-shelf natural language systems as well to make sure we're covering all of our bases.
Oh, sorry, I was on mute. Thanks for the response, Mark. So I have a related question from another member in the audience. They're asking, Are you using any known algorithms such as regression analysis, logistic regression, or are these algorithms created by you? And after that, I'd like to have Corey chime in and talk about some of the algorithms that are available on DataRobot.
Yeah, that's a great question. And so all of the stuff that is custom to StoryFit is about measuring the elements of the story. Once we get that structured data set of features of the story, we plug that into traditional existing algorithms, whether they're machine learning regressions or, as you mentioned, could be just logistic regressions. So the part that's custom to StoryFit is measuring these elements of stories and narrative. And then we leverage platforms like DataRobot that already provide built-in versions of all of these different machine learning models, whether it's more traditional machine learning or neural net-based models. But really the unique part that we're building in-house and custom is specifically the measuring the story part. And so that's why this technology and using something like DataRobot really applies to any industry, is that once you've got the core set of data and features that you care about, all you want to see is which model is performing the best and giving you the most accurate results. So we've been able to scale up and really rapidly test out whether a Nystrom kernel SVM versus a gradient boosted tree performs better on the same data set really quickly and really accurately.
Yeah, I think that's a great question, and I think it speaks exactly to why StoryFit is such a good example of using DataRobot effectively, right? If you're thinking about your data science capacity, what's really valuable is that feature engineering piece, and that's what your team does better than anybody else. Once you get to the point of having done that feature engineering, which model is gonna edge out and create the best results, that part you kind of just want that to work. Right, and that's what DataRobot lets you do. So our approach is we've gone out to open source solutions, so Python R, XGBoost, which folks who are familiar with data science competitions in Kaggle will have heard about, TensorFlow, which is neural networks, a really wide variety of the data science landscape, as well as some of the models which are proprietary to DataRobot. We've got some things that we've developed and we maintain as well. And the idea is that we've gone out, we've sourced all these things, we've identified best practices around them, we've encoded those in those blueprints. And so when we're trying a new data set, it really is figuring out which methods are gonna work best for that problem. And that can be defined by the data, but also the business problem. So we do work in industries where there are restrictions on what kinds of models you can use, and obviously we can accommodate that as well, so that your data scientists are focusing on the machine learning, on the business problem, on the feature engineering, the things that are unique to that problem, rather than what's the learning rate that works the best here, which we can do for you.
Thanks, Corey. Let's see here, just going down, we got a lot of questions. This is great to see. We may have to follow up with some of these questions since we have so many. So let me pick one out. All right, so I have a question here, and this is for Mark. Question is, does StoryFit employ any generative machine learning algorithms in its analysis? The reason I ask is because I'm concerned that using StoryFit's models will crush creativity by making new stories too long like old stories. Since we're helping studios to base investment decisions over what has worked historically.
Yeah, that's a great question, and I think it really has two parts. One about generative models, and so the answer to that is no, we're not using any generative models to create content. We are really using our technology to study existing narrative in a way that has not been quantifiable in the past. And that is definitely something at the top of our minds when we're working at StoryFit, is how we can fit into the creative processes without stepping on toes or making anyone uncomfortable. And so we've found that by just putting this data set of story features in the hands of creatives is the best way to empower them to make the most informed decisions about their content. So we are not in the business of giving prescriptive diagnoses for a particular screenplay and saying, hey, if you want to hit a larger audience, you need to pump up the number of characters you have. What we're doing is providing a data set that allows anyone working on a creative project in the entertainment industry to have the most accurate benchmarks of where their content fits into the existing market landscape. And so we're very cognizant of all of the implications of this technology, and have made sure to stray away from anything generative, because that is really something that remains in the creative realm, and we are providing analytics to empower creatives, not doing anything to step on their toes.
Great, excellent response, Mark. Okay, let's see, next question. This is a question for Corey. How much manual tweaking of features and attributes are needed during training and evaluation? Can you give an example?
Sure. So the DataRobot, as I kind of mentioned at the end there, the idea is that you can do all the generative parts of model creation in DataRobot automatically. So DataRobot will generate the models for you given the data that you've imported. It'll do hyperparameter tuning. It'll, compare 70 or 90 or 100 different blueprints to find out which ones are working well. It'll set aside holdout data automatically. It'll make some smart decisions around things like what accuracy measures to use, how to do sampling if you have something like imbalanced data. All of that is automatic to the platform. We do have some use cases where we have teams of data scientists who have particular expertise about certain methods and really want to, test their own prowess against DataRobot. So let's say a situation where, you're a massive bank and, 0.5% more accuracy is going to equate to millions of dollars saved a year, right? That's where it may make sense to spend time, trying to beat what DataRobot has done. And if you do that, great. We'd love to hear about it so that we can continue improving on those blueprints. But for the majority of use cases, what DataRobot gives you out of the box is gonna be a really good place to start from. And then if it isn't, those marginal gains are usually not meaningful.
I think one thing that's useful too is that, so StoryFit has been using DataRobot for about 1.5 years now. And prior to leveraging their platform, we built all of our machine learning predictions in-house. And we would not have moved to using DataRobot if we didn't find comparable accuracy in our in-house trained models and the ones that we've trained on DataRobot. So really, we have done that benchmarking and evaluation and found that accuracy was extremely comparable, and that the advantage of using something like DataRobot is just the scalability, that we can have 35 machine learning models in our production ecosystem with only a team of 6 engineers and data scientists. So it's very comparable accuracy to what we could do with tons and tons of manual tweaking of our own models in-house, and has been a really valuable asset to scaling up.
Great, thanks, Mark, Corey. So I have another question from another participant, just a little more detail and focus around overfitting. The question is, how does DataRobot deal with generalization and overfitting? Verbatim, this is what they're asking, as it tries many different models, even if it's using cross-validation, when you use repeatedly on 75 models, how to avoid data mining? But I think in a nutshell, they want to understand, what in the automatic model tuning capabilities, what does DataRobot have to help data scientists avoid and deal with data overfitting problems?
Yeah, absolutely. It's a great question, and it's something that we do a lot of thinking about. So automatically, DataRobot's going to set aside 20% of your data out of the box as a holdout sample. That's going to vary a little bit if you have very small data, but 20% is the default. And you only unlock that after all of your hyperparameter tuning is done. So all of the leaderboard creation, generating testing models, all of that happens before you unlock your holdout, so that when you unlock that holdout at the end, you're honestly seeing completely out of sample data as well. So cross-validation is also out of sample because we're looking at subsets of data in training and testing, but that holdout is completely fresh. So that's one of the ways that we would look at it. But you're also looking at accuracy, again, that first pass validation, the cross-validation, and the holdout sample in addition to make sure that we're not overfitting.
Thanks, Corey. Okay, so we're at the top of the hour. There's still a lot of questions left. We're going to follow up with responses by email. But this concludes our webinar. I'd like to thank all our participants. We hope this webinar has been valuable. And I'd like to thank my guests, Corey Kynes and Mark Bezin. And this is Dylan Tong in AWS signing off. Thank you, everyone.